After discussing the various options to limit our energy consumption in the previous video, we will now deal with the question of how we can supply the remaining energy in a climate-friendly manner. There are many energy sources with very low associated CO2 emissions. Firstly, we have a variety of renewables like solar, wind, bio and geothermal energy. We also have hydropower and various so-called ocean energy sources. Next to that, we also have nuclear energy and fossil energy with carbon capture and storage. Let us first focus on the renewable energy sources. The good news is that they are abundant. There is a famous saying that every hour the amount of energy that reaches us from the sun is more than what the entire world consumes in a year. This means that the amount of solar energy available is about 10,000 times the amount that we use. But the downside is that a renewable energy source is very dispersed. If you look at two important sources like solar energy and wind energy, we see that the energy flow on an annual basis is a few thousand kilowatt-hour per square meter. That is the amount of insolation that reaches a solar panel or the amount of energy that is flowing through the rotor of a wind turbine. But if we look at the actual density of energy production, we of course get much lower numbers. Solar panels now have an efficiency of about 20%, and of course if you put them on land, you need sufficient spacing between the modules, leading to energy production of a few hundred kilowatt-hour per square meter. Similarly, wind turbines also need to be spaced at substantial distances from each other to avoid interference. And finally, if you look instead at bioenergy, we see that the energy production density is even lower. This is due to the fact that plants are not very efficient energy converters. The efficiency which they convert to solar energy into energy-containing materials is much less than 1%. So this all means that we need large areas of land to harvest renewable energy. It should also be considered that the land used for renewable energy can often be used for other purposes at the same time. Let us now have a further look at electricity. As we already noted before, the role of electricity in the energy system is becoming increasingly important. Fuels are currently the dominant source of final energy used for industrial heating, space heating and transport. Electricity is only dominant for stationary power and to some extent for space heating. In the future, this will change, as electricity will provide a much larger contribution for a diverse range of applications, from industrial heating to passenger cars, and moreover, it will also be used to produce fuels. Presently, fuels are mainly converted into electricity, but in the future, electricity will also be used to produce hydrogen and other fuels. Renewable energy sources already play a substantial role in global electricity production, about 27%. The most important one is hydropower, with a share of 16%. The new renewable energy sources, like wind energy and solar energy, still have a very modest role, although they are growing rapidly. Next to this, also about 10% of global electricity production is produced by nuclear power. For the future, wind and solar energy are considered essential energy sources that will likely play a dominant role in the low-carbon transition of the electricity sector. Wind energy can be produced both at land and at sea. Especially offshore production of wind energy is rapidly growing. We see larger and larger wind turbines now with capacities already beyond 10 megawatt each. For solar energy, the most applied technology is photovoltaic solar energy conversion. This is a solid-state conversion process which converts solar energy directly into DC current. Solar energy can be applied on buildings or other structures, which we often indicate as rooftop PV, but also on a larger scale on dedicated land areas, which are indicated as utility PV. Utility-scale systems can be up to 100 megawatt or more. Other technologies, like some concentrating solar power technologies, still play a very modest role. As we indicated earlier, nuclear power and hydropower already play a substantial role and in both cases could further grow in the future, although in the case of nuclear power, the growth is limited by lack of social acceptance. For hydropower, there are also physical limitations to the number of sites on which hydropower can be applied. As we saw, the share of wind energy in total global electricity production is about 6%. But it's good to know that in some countries this number is already a lot higher. For example, in Denmark, where it is above 60%. The share of wind energy in the USA is about 8%, and in China it is 6%. Also, for solar energy, we see a rapid growth in several countries. The global share is modest at 3%, but we see several countries already having shares of 7 to 10% in electricity production, including countries like Chile, Australia and Japan. This rapid growth is to a large extent generated through the presence of supporting policies. The most important one has been feed-in tariffs. Feed-in tariffs are very simple. They provide a fixed fee for each kilowatt hour of electricity that is produced, effectively subsidizing renewable energy. There are numerous variations to these systems, but similar systems are already present in over 100 countries, as you see on this slide in grey. Additionally, there are renewable energy obligations, also called renewable portfolio standards, in which case energy companies are obliged to have a certain percentage of renewable energy in their total production or retail portfolio. And the newest policy measure are renewable energy auctions or tenders. In an auction, renewable energy project developers are invited to submit bids for their proposed price per kilowatt hour, and the lowest bidder gets the contract. As you can see in the picture in yellow, this policy type is rapidly gaining popularity over the last decade. Auctions are believed to contribute to lower prices. Indeed, part of the significant cost reduction in recent years of solar and wind energy can likely be attributed to such competitive bidding systems. In some areas, it is already possible to produce renewable energy at prices of $1 or $2 per kilowatt hour. In any case, renewable electricity has become quite affordable across the globe, and there is hardly any reason not to rapidly pursue the deployment of such sources to cut fossil fuel power generation and associated greenhouse gas emissions.